Hey everyone, welcome back to yet another Euphoria Academia YouTube video where we do past papers. Today we're going to be doing the Mathematics Paper 2, May-June 2023 paper, and we're going to be doing question 4. My name is Ole and I'll be taking you through it. Please like, share and subscribe if you find any of our videos useful. So without further ado, let us get into it. As I said before, we're going to be doing question 4, and question 4 ranges from question 4.1 all the way up until 4.4.2, and it's 22 marks. And according to exam guidelines and tips and tricks, you should take about 22 minutes to complete this question, but it's not a hard and fast rule. So let's see what they have for us. And yeah, let's start with the first question. Alright, for question 4.1, we're asked to write the coordinates of M. And M is the center of the big circle, and we're already given the formula of the big circle, and it was stated as x plus 6 squared plus y plus 3 all squared equaling 25. And from that formula we can tell that the center, which is M, the coordinates will be minus 6 and minus 3. Question 4.2.1, we're asked to find the length of the radius of the smaller circle, and we're not really given much except the formula of the smaller circle, and it's not really written in standard form. It's written as x squared plus y squared plus 24x minus 10y plus 153, and that is equal to 0. Alright, so we have to write it in standard form, and if we get it in standard form, then we can get the length of the radius. Now, with these types of equations, especially with equations of circles, you need to be able to do completing the square. So let us write in a way that will allow us to write as well as completing the square. Alright, so we're going to say x squared, we need to have an x next to it, plus 24x plus y squared, we need a y next to it, minus 10y is equal to, we're going to take the 153 to the right hand side, so we're going to have a result of a minus 153. Now with completing the square, you should always try and write like things on the side so that it becomes easier when you need to factorize. Alright, so we're going to start with the x squared and the x. Now to complete the square, we need to find half, or we're going to, half times whatever coefficient x is, and that is 24. And we need to square the result of this multiplication. I always like writing this step or the following step because it's going to help us with the factorization. So half times 24, that is going to be 12, and we just need to square 12, and we're going to get 144. Alright, now the next one will be for y, and we're going to do the same thing, just that we're going to have a different multiple, to say the least. So we're going to multiply minus 10 by half, and we're going to square that result. Like I said, I like writing the second step because it's going to help us with factorizing. So half times negative 10, that is negative 5. And we're going to square that, and we're going to see that we're going to get 25. Alright, so we know what we need to add and such things like that. But with completing the square, if I add 25 to this, or I add 144, essentially we're changing the equation. So what we need to do, yes, we can add it, but we also need to subtract it at the same time so that we actually don't change anything. But with the subtraction, we're going to move it from the left hand side to the right hand side. But I think let me just write it out to make things clearer for everyone. Alright, so we have x squared plus 24x plus 144 minus 144, because we don't want to change our equation, and we have plus y squared minus 10y plus 25 minus 25, and that is equal to negative 153. Alright, so the minuses, so the minus 144 and the minus 25, we're going to move to the right hand side, which means we're going to add, and then we're just going to factorize the left hand side. Now it easily factorizes because we already know what we're going to add to the x or the y. And what I mean by that is that we're going to end up with a situation where we have x plus 12, square that, and we're going to add a y minus 5, and we're going to square that. Where do we get those? Well, the minus 5, we get it from there, the 12, we get it from there, and that will be equal to, we're going to say minus 153 plus 25, because we're taking this minus 25 to the right hand side, and we're going to say plus 144 because we're taking this minus 144 to the right hand side, and we're going to end up with a result of 16. Now we know that in this standard form, this constant is actually r squared, and we're asked to find the radius, so just a normal r, so that would mean that we need to square root our 16, and we're going to see that the radius of the smaller circle is 4 units. Alright, so in question 4.2.2, we're asked to find the length of TS, and TS is the gap in between these two circles. So that gap there is TS. So what we're going to do is we're going to find the length of NM, so the distance between the two circle centers, so from N all the way up until M. And then what we're going to do is we're going to subtract the two radiuses, and we're going to be left with that gap right there. So let us do it. So at first we're going to use the distance formula. So NM will be equal to the square root of ym minus yn squared plus xm minus xn all squared, and we're just going to substitute what we have. And what we will have, we're going to have a minus 3 minus a 5 there, and we're going to square that result, plus a minus 6 plus 12. I'm going to square that, and the result that we're going to have is 10 units. So we have the full distance of NM, and then what we need to do then is subtract the radii from this 10 to find that small gap TS. So we know that the radius of M is equal to 5, the radius of N is equal to 4. So therefore TS is equal to 10 minus 5 minus 4, and that will give us 1 unit. For question 4.3.1, we're asked to find the equation of the tangent PR. Now we know that PR is parallel to the x-axis, and because it's parallel to the x-axis, it's going to, or its equation, it's going to be in the form of y equals to some constant. Alright, so that means we just have to find the y coordinate of either r or p. Alright, so we know that this thing is a tangent, and where r is, that's where PR actually touches the big circle that is centered at M. So where it touches it, we know that the radius is perpendicular to the tangent, and if you draw a perpendicular line from M up until R, you will find that R has the x coordinate of minus 6, and then we know that M has the coordinates, or let's just look at the y coordinate of minus 3. So that means from the x-axis we move 3 units down, and then going to R, where R is, that will be on the circumference of the big circle, just actually equaling the distance of the radius. So the y coordinate of R is actually going to be the minus 3 minus the radius of M is 5 units, or minus 5, and that will give us minus 8. Now if we have the y coordinate of R, we have the x of R, so minus 6 and minus 8. We said that the equation of the tangent is going to be y is equal to some constant, which is actually the y coordinate of R, or as well as P in this case, because it's the same point, right? And it's the same line. So therefore the equation of PR is y is equal to minus 8. Alright, for question 4.3.2, we're asked to find the equation of PS, which is also still a tangent. Alright, so we can see that PS runs from point P all the way up until S, and it touches the big circle, but it also intersects this line NM. Alright, and wherever it intersects, well, this is from center to center, and if this is going from this center to the circumference of this circle, well, that is the radius, and wherever that this tangent touches the radius is perpendicular. So that means the gradients of PS as well as NM, when you multiply them together, they're going to give us a result of minus 1. Right, so we already know how to get there. We just need to get the gradient of NM or MN. It's up to you what you call it. Alright, so let's look for the gradient of NM, and that is going to be ym minus yn over xm minus xn. Right, now we're just going to substitute, and when we substitute, going to see that we have a minus 3, and that is going to be minus 5, and then at the bottom we have a minus 6, and then we have a plus 12, and our result is going to yield minus 4 over 3. Alright, like I said, when you multiply the gradient of nm and ps, you're going to get negative 1. So let's find what the gradient of ps is going to be. Alright, so you can either write it down, or if you know it, you just have to find the inverse of this as well as the negative, well in this case the positive, which is going to be 3 over 4. But for completeness, I think let us just write the whole sum. Alright, it's going to be equal to negative 1. Therefore, the gradient of PS is going to be 3 over 4. Now we're looking for the equation of PS. So what we're going to do is we need to, well, we have the gradient and we have a point. So we're going to use the gradient point method. The point that we have is K. K is on the line PS, and that is minus 17 and minus 5. So what we're going to do, the equation will be written as y is equal to mx plus c. We're just going to substitute in k. We're going to have minus 5 is equal to m was 3 over 4, and that will be multiplied to our x of minus 17 plus c, and we're going to see, no pun intended, that c is equal to 31 over 4. Therefore, our equation is y is equal to 3 over 4 x plus 31 over 4. Question 4.4.1, we're asked to find the perimeter of PSMR. So at first, I would go looking for where PSMR is. So there's P right there, and PSMR will be this purple line here. Apologies for the lack of straightness. So that quadrilateral right there. Right, we need to find the perimeter, and a perimeter means that we have to find the distances of all those sides and then add them together. So essentially we need to have a situation where we have PS plus SM plus MR plus RP. We need to find what this equation is going to equal. All right, now let's see what values we need and what values we have. All right, so PS, that's something that we don't have. All right, SM is this radius here, so it's the radius of the big circle. SM will be 5 units. MR will be 5 units, and then RP is this tangent over here. All right, this is tangent over here, but we can see that RP originates from P and goes to R, and then PS originates from P and goes to S and touches the same circle. All right, so we already know that PS is equal to RP because we have tangents from the same point. Tangents from the same point. Alright, so that essentially means we need to find either PS or RP. Alright, and the longer way would be to find the coordinates of P, then find the distance of PS or RP. Alright, but there's an easier way because we know that PR is actually parallel to the x-axis. So we just need to find the differences, or the distance between the x-coordinate of P. So we need to find the distance of the x-coordinate of P. So xp will be there and xr will be there. So we need to find this distance here. Alright, so we need to find that distance between there, and then we'll be able to see actually how long PR is, and conversely how long PS is. Alright, in order to do that, we need to find the x-coordinate of P. Now already we've determined that R is -6 and -8. Just wanted to write it there to get it out of the way. Alright, now how do we find P? Now, because P lies on the same line as R and PR is parallel to the x-axis, we know that P has the same y-coordinate as R, and that is -8. So we just need to find what xp is equal to. Well, we have an equation for the line of PS, and we have the y-coordinate of P. So let's substitute the y-coordinate and see what x-coordinate we end up with. Right, so let us substitute. So when we substitute, let me just write out the whole equation. So the equation is y is equal to 3 over x plus 31 over 4. And if we substitute, we're going to substitute -8 is equal to 3 over 4. And we're trying to find xp plus 31 over 4. And after doing some calculations, we find that xp is equal to -21. Now, how are we going to get that distance of xp and xr? Well, we have -21 and the other one is -8. So we essentially need to find the difference between them to see how far apart they are. And apologies, not -8, it's -6. And we're going to see that the difference between them, or the answer that we're going to come out with, is going to be -15, but we're speaking in terms of length, so this is going to be just 15 units. And as stated before, this is the distance of PR, and PR is also equal to PS, as we stated in the beginning. So we have our 4 equations. So the perimeter of PSMR is going to be equal to 15, which is PS, which is actually PR because they're equal. 15 plus 5 plus 5 plus 15, and we're going to end up with an answer of 40 units. Right, for question 4.4.2, which is the last question, we'll ask for the ratio of the area of triangle NPS over the area of the quadrilateral PSMR. Alright, so what we're going to do is just substitute our formulas for each, and then we're going to see what we end up with. So the area of a triangle, any triangle, is always going to be half base times perpendicular height. Now, what's the base of triangle NPS? Triangle NPS, let's try and look for it here. Triangle NPS is this triangle over here in NPS. So yeah, the triangle in blue, the base will be NS. Alright, so let me just quickly switch pens. So half of the base NS multiplied by the perpendicular height PS. Alright, now for the quadrilateral, what's the equation of our quadrilateral? Well, it's half the product of the two adjacent sides. So I think let us start with the SP multiplied to MS plus the half of the other adjacent side product, MR multiplied by PR. Okay, so let us just substitute what we know for sure. I'm not gonna write these halves because half divided by half is 1, so they're going to cancel each other. So NS is actually NT plus TS. So let's do that. NT plus TS, and all of that is multiplied to PS, which we already have a distance for. And then at the bottom here is P, which is PS as well, multiplied to MS plus, yeah, so if you just take out a common factor of half, which is going to be left with SP plus MR, yeah. So yeah, that checks out, plus MR multiplied to PR. MR is the radius, PR we also have. So let us just do some substitutions. So what we have is, well, actually we can do some further, yeah, we can do some further simplifications. But I think, yeah, let's just do some substitutions and see what we have. So NT is 4 plus, and TS is 1. PS we said was 15. Yeah, PS was 15, and then SP is also 15 multiplied by MS, 5 plus MR. MR is also 5 multiplied to PR of 15. Now, if you enter that into your calculator, don't have to give yourself a headache, you will see that our final ratio is half.